In this video, we're going to be talking about how to find the matrix of a 2 by 2 matrix. Okay, so it's a very simple formula that you need. I know it might look overwhelming, but after a little bit of practice and a few of the examples I'm going to show you, you'll understand that it's actually quite simple. Okay, so let's jump right into it. So if we take a 2 by 2 matrix, call it A, okay, and we'll call the elements in it A, B, C, D in this format. Okay, make sure you get it in this format, like A, B, C, D. Don't like mix up B and C, like just do it in this order. And then the formula for A inverse is going to be 1 over the determinant of A, which I'll probably make a whole other video on how to find the determinant of matrices. But for a 2 by 2 matrix, it's very simple. I'll show you what it is right now. Negative C and A, where the determinant of A is equal to AD minus BC. Okay? So what this means is that when you have the matrix A, or it's a 2 by 2, where you have elements A, B, C, and D, okay, to find the inverse, you simply swap A and D, right? So you go from A here to A here, and D, so you literally just swap them around, and you negate B and C. So B and C stay in their same positions, they just become negative, but on the diagonal, the other way, you just swap the elements, okay? That's all you do. And then you do you multiply the entire matrix by scalar, where it is 1 over the determinant, where the determinant is calculated as the product of A multiplied by D minus B multiplied by C. That is it. Okay, so let's go ahead and take a few examples so that you can familiarize yourself with the process. And real quick, actually, before we get started, something to note, that if the determinant of A is equal to 0, the inverse does not exist. D and E does not exist, okay? And you can see this because if the determinant is 0, we would be dividing by 0, which is undefined, okay? So let's go ahead and start with an example. Let's say A is the following: 2, 3, 1, 4, okay? I'm gonna get started by finding the determinant of A, where in this case, this is A, B, C, and D, right? So it's AD, so 2 times 4, minus BC, which is 3 times 1. And this simplifies to 8 minus 3, which simplifies to 5, okay? And then you simply apply this operation, where you swap the diagonal and negate the two sides. So what I go ahead and do is I get 4 and 2. Since I swapped those around, I get negative 3 and negative 1. Okay? So I get that. And then I multiply by 1 over the determinant, which I just found to be 5. So I get 1 over 5. And if you want, you can expand and just multiply this out. You'll get 4 over 5, negative 3 over 5, negative 1 over 5, and 2 over 5. And that's it. That is the inverse of A. Okay, so nice and easy. Let's go ahead and do one more. Let's say we have A is equal to 3, 4, 10, 2. Okay, and let's make this negative as well. Okay, so we're going to go ahead and find the determinant of A, which is 3 times 2. Okay, so you're multiplying this and this, and then subtracting by this and this. Subtracting by negative 10 times 4. So this is 6 minus, this is going to be negative 40. So 6 plus 40, because the two negatives, you make a positive. Negative, negative becomes a positive. You get 46. Okay? And then the operations that you do on the matrix, you swap 2 and 3, and you negate the rest. So you negate 4, and you negate negative 10, making it 10. Okay, and then you do 1 over the determinant, which is 46. And here I'm just not going to expand. You can, depending on what your question needs from you. And this is A inverse. Okay, so let me go ahead and show you an example where the inverse won't exist, where the determinant is 0. So let's say you have a matrix 3, 2, and 1, 6. Okay, at first glance, it just looks like a regular 2 by 2 matrix, but the inverse for this actually does not exist. And the reason for that is we said if the determinant of A is equal to 0, then the inverse of A does not exist. This is very important. So if we find the determinant, we find it to be 3 times 2 minus the other diagonal, right? So you go this way, you multiply these, and then you subtract these products together. So 6 by 1, you get 6 minus 6, which is 0. So the inverse of A does not exist. And that sums up the inverse and finding the inverse for a 2 by 2 matrix.